In this video, we will discuss about Pascal's law. Many people define Pascal's law as the pressure exerted is same in all directions at a point, but it is not the actual definition. The Pascal's law is stated as pressure applied to confined fluid increases the pressure throughout by same amount. So what is it telling us is, we have seen in the last video about the pressure distribution in this way. So if this was atmospheric pressure, it is like this. It was like this. So this was the pressure force distribution. And if we do not consider this atmospheric pressure, or if it is represented in terms of gauge pressure, the pressure distribution will be in this way. So if the atmospheric pressure is considered, the same amount of that amount is added at the surface. This is the atmospheric pressure. So the same amount is added here, and the same amount is added here, same amount is here, same amount added here. So that is what it is indicating. So if this is the initial condition, and if I am increasing this pressure, so with the piston I am increasing this pressure, so it has increased from 0 to, say, suppose here, up to here it has increased. So the pressure distribution will be in this way. So the same amount of pressure is increased at each and every layer. This is what it is indicating. When applying the Pascal's law, these 2 points should be remembered. The pressure is same in all directions at same level below the free surface. We have seen this in last video. Pressure is same in all directions at same level below the free surface. So if we consider this figure, if we consider a point here, the pressure will be P, 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 P in all directions. If we consider the same point at the different point at the same level, here it will be P, 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 P in all directions. So that is what the first one is indicating. If we consider a point below the point first we consider, here there will be some excess pressure, let us say PE, PE. So this is what the first point is indicating. The second point is the resultant hydrostatic pressure force acts perpendicularly on the surface. So the combination of these two laws gives us, or let us see the second point individually. So the resultant hydrostatic force. So this is the surface, and the hydrostatic force here will be acting is perpendicular to that surface. So if we consider a point here, there will be hydrostatic pressure force acting that way perpendicularly. If we consider this point here, it will be in this way. If we consider this here, it will be acting in this. Combining first and the second points, we can get this way. So the points at same levels, this one, this, and this. So these are points at same level. The pressure should be acting same at these all points. So now there will be hydrostatic pressure force acting in this way. Here the perpendicular to the surface is this, and the perpendicular to this curved surface is in this way, and for this in this way. This is how the pressure force will be acting, and for this it will be in this. And if there was any surface like this, suppose say if there was surface like this, and this is the level we have considered, and if the pressure force acting here is P, here also, and at the same level, the perpendicular to the surface, here also there will be acting P. So here, let us say P1 is acting, here also P1 will be acting, here P1 will be acting, here also P1, 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 like that. So perpendicular to the surface, that will be acting. So these two are needed, these 2 points are needed to apply the Pascal's law. Let us understand this Pascal's law more detailedly with an example. So here there is a car which has force F2, and we are applying a force F1. So which force is greater, F2 or F1? Let us see now. Here the application area is A1 and pressure is P1 due to force application. The area here is A2 and the pressure is P2, so that this F2 weight is lifted up. So we have seen that in Pascal law, the pressure, the applied pressure will be the applied pressure is added to each layer. So if the applied pressure is added here, so the same amount of pressure is added in this way. So here also it was like this initially, and due to this application of pressure, the pressure distribution will be in this way. So this, if P1 is applied, there will be a same pressure here also, P1, P1. So here P1 is equal to P2. Since this is because P1 is equal to P2, because these both are at same levels. So at same level, the pressure will be equal. And also we have seen that the force, pressure force will be acting perpendicular to the surface. So here this pressure force will be acting perpendicular to the surface. And now, so here P1 is equal to P2. So P1 is F1 divided by A1. Force by area is pressure, which is also equal to F2 by A2, since P1 is equal to P2. So F1 into A2 by A1 is equal to F2. So here from the figure we can say that A2 is greater than A1. So this will be greater than 1. So that F2 is greater than F1. From this we can say that to lift a larger weight, we need a smaller force. So F2, to lift a larger weight, we need smaller force. This is the advantage of Pascal's law. So this is how the Pascal's law is applied.